The third section. Application. So let's solve the following equation that we have seen actually in the introduction in the first video. X equals 0. Find x. So this is fx. But as I said, we need an interval. We need to find, before to apply the method, we need to find an interval AB where the function or the curve of the function cross the x-axis. So we need to draw f with respect to x. So, or in the images of x with respect to x. How we do that? We use MATLAB. So this is the first thing to do. If you don't have in exercises for tutorials, I will give the interval one. But if you have, for example, a mini project or you have an equation without the interval, you should draw it. How to draw it? It's very easy, very simple with MATLAB in 2 instructions. So first of all, you have to define your function f. Name it f or g or whatever you want, and then at, symbol at, like in email, at, then parenthesis, and inside the parenthesis you put the independent variable, and then you write the body of your function, the body of the function of f. So here in our case it's xp, exponential of minus x minus x. So the independent variable must coincide, of course, with the variable you use in the body. If you use, for example, time t, must be a t, for example, or any variable. You can name it whatever you want. You can also have function with multiple variables. So x, comma y, comma z, for example, and you have here the expression of. But here, in this chapter, we work with a function with one variable. So, and you add a semicolon. A semicolon is optional now. Is optional. If you add it, f, the handler of this function, it is called the handler. The handler is stored in the memory, but it will not appear in the console. If you do not add semicolon, it is stored, and in the same time, the result of what contain f is showed, is displayed on the console. You have a console where you write the command. This is a command. You write the command, you tap enter, and it is executed. MATLAB is a script language. It executes the command one by one. You write the command, it interprets it, and then execute, and then it goes to the second command, and so on. It's not like other languages called compiled languages. They study, the compiler study or analyze all the commands, and then rewrite them in an assembling language called assembling language, and then is executed by the machine. But in MATLAB, it's much simpler. You write the command, you type enter, it is interpreted and executed on the spot. So this is the semicolon is optional. And the second instruction is to plot. This is to define your function. And the second is to plot. It starts with f for function, fplot. Fplot is a function, a built-in function in MATLAB. Its goal is to draw the function. Parentheses, and you give the input. The first input must be f. All the functions that start with f, their first argument must be the function handler, f or g or whatever you have called it here. And then you give the interval where you want to draw your function. I don't know where it cuts, so I chosen -5 and 5. Maybe it cuts between -5 and 5. Maybe not. If not, then I increase the interval. I use -7 plus 7, for example, and so on. So, but it cuts actually between -5 and 5. And I close the parentheses and the semicolons. Here is not necessary because there is no variable here. Here we have stored the handler in a variable, but here there is no variable, so you can omit semicolon. But I used to use always semicolon, so it's okay. And once you do these two instructions, a new window pops up, and you will see the following figure. Let's draw it carefully. We have here 4. And we have here of course with MATLAB it's very fast, but here I have to draw it carefully for pedagogical reasons to be clear as possible and to respect the scale. Okay. So this is the x-axis and the y-axis. We have here 1, 2, 3, 4, and here same 1, 2, 3, 4, 5. And our function will start here 0, 40, 80, 120, 160, -40. So it grows very fast, and it should be like this. And we find that it cuts between 0 and 1. And you have 4 -4. And find it is the interval. We see from the figure that our interval is 0, 1. We could choose, of course, 0, 2 or -1, 2, but the smallest I can see is 0, 1. So from the graph, I conclude that our solution, our root, belongs to the interval I, 0, and B, 1. So this is the first task to do if you do not have the interval AB. You use I advise to use MATLAB. It's very easy, but you can use, of course, any graphical device. Some calculator actually can draw a curve. So it depends on what you have, but in MATLAB, as you see, 2 instructions. It's very simple. you define the handler of the function, and then you call fplot. With a given interval, choose it large enough, and if it's not enough, increase it until you find where your curve cuts the x-axis. If you have a function that has multi-roots, choose the root you want to study, you want to find. Because here I know the solution here, but I don't know exactly how it is equal to. So that's what we do with what will we do now with MATLAB. Now let's check my notes. And we need a table. Second here, we need a table. We need to draw a table. So we will apply the Kamel method through a table. Now we need a space here. For the iteration. So let's say for the error, and for the titles. And in this table, we will have each line or each row will represent an iteration. And with a pen and calculator, we will not exceed. I used to teach with my students more than 5. It's more than 5 iterations. It's too much. So I will not exceed 5 iterations. But of course, with a computer program, you can do as much as you want. And continue the number of iterations. So here the iteration, here is XL, the lower bound, and its image, the upper bound, and its image, and XR, the force point method. Here we apply the equation of the force point method, and its image, and the error, approximate error, that measure the progress of XR along the x-axis. And as you can see, you have the position and its image, the position and its image, the position and its image. So they go by pair. This is the first iteration, the second, the third, the fourth, and the fifth. It's very hot, the weather, anyway. So we have the function exponential of x minus x equals 0. Find x in 0, 1. And you are given the interval 0 and 1. And as I said before, the error at the first iteration is always 100%. And that's it. This is f. That's it. This is the input. Now you have to know, practicing in exercise, in this example, of course, and the exercises once, twice, 3 times, and you will learn the method. It's very easy, very simple. And in this section, you know how to fill the cells of this table, how to apply the method. And let us report the 3 rules, because we need them here. XR at the ith iteration, this is the Abou Kamel method, the chord with the x-axis, using the similar triangles. So FU xl minus fl xu over fu minus fl. Of course, I have iteration, but I will not add I for clarity, just to keep things clear enough. And the second, this is the first. Second is the error. At the ith iteration is the current iteration minus the previous one over the current one by 100%. And the third relation is the sign. If the sign of fl at the ith iteration is different from the sign of fr, not u, fr, the image of xr, of the false point, is different, have different sign than it is at the left. Otherwise, it's at the right. Sign here is a function in MATLAB that return one if it is positive, if the value we give is positive. Return -1 if the value we give is negative, and it is 0 if the value equals 0. So if they are both positive, we get here 1, 1. And they could not be different, so it's at the right. If one is negative and the other positive, you get -1 and +1. And so they are different. So it's a simple rule to apply. You don't have to make any multiplication. And let's start. So we need a calculator. You can, if you are watching me, you can stop the video and bring your calculator and try at least few cells, at least the two first iteration. Try with me. I will make a stop, a break, so that you have time to use your calculator. If you stay passive, just watching, you will never learn. You have to practice. You have to use your calculator. And I said that to my students many times. Anyway, they had very, very bad students. Not bad people, but bad students back in Algeria. The majority of students, their level is so, really so bad. But yeah, so let's, not all, of course, some are good students. So let's apply the rule. We take 0 in f here, exponential of -0 minus 0, we get 1. Here it's easy, you don't need a calculator. Then 1, we replace it here to get its image. And with a calculator, we find the following number. I will write it. So you get time to use your calculator and to check with me. I generally use 3 numbers. I stop with 3 numbers. I limit, the result to 3 numbers after the comma, 3 decimal numbers. So I write here -0, 6, 3, and that's it for the first, the interval and the images at the endpoints. And check that they have different signs. This is positive, this is negative. If you find here plus, you have done a mistake. Then I need the Abou Kamel method to calculate the false point. I replace here the values and get, I will do that here. So iteration number 1. XR at the first iteration. The rule tells me work with the images at the numerator and denominator. FU first. So I take these two numbers and put them here. I write -0, 632. Let space here, leave a space, and 1. Leave another space for the x, the x's, and then repeat exactly the same. -0, -0, 632, -1. And here I will put the x. So the x, L, and U. So they go in that direction, 0 and 1. 0 and 1. And with a calculator, you find 0, I found 0, 6, 13. I report the value in the table, 0 with a black color, 0, 6, 13. And here also it's important that your XR should be always between 0 and 1. It's bracketed by this interval, by 0 and 1. In all iterations, always check XR is bracketed. If you find, for example, 1.2 or -1 point something, don't continue, it's false. All the rest will be false. So make sure your value XR, you don't know, of course, if it's true or false, but make sure, I mean, you are not sure exactly that the calculation is correct, but at least if it is outside 0, 1, you are sure it's not right, it's wrong. So 0, 6, it's a way to check the value you do here in calculation. 0, 6, 13, then I take this value to the image and get the value. So FR1, I use the colors for pedagogical reason, it's important. It's the image of XR1. This is XR1, it's the image of XR1. So I take XR1 and put it in F with a calculator, of course, and I obtain the value minus 0, 0, 71. And I report it here, minus 0, 0, 71. Okay. A error might be positive, negative, it's okay. Important thing is its absolute value will decrease towards 0. While we go through the iterations, it must decrease in its absolute value. So we have finished the first iteration. So it's very easy, very simple. You find the images of the endpoints, then you apply the Abou Kamel method to get XR, then you apply F to get its image. And that's it. That's it. Now let's move to the second iteration. For the second iteration, we need the rule of the signs to decide at the left we have to go or at the right of XR. For that reason, we check the sign of FL and FR of the current iteration, the ith iteration. So the sign of FL and FR are different. This is positive and this is negative. So it's at the left. The curve has crossed the x-axis at the left. It was positive, and before to reach XR, it became negative. Before to reach FR, I mean, it became negative. So the next interval will be at, let's write it here. Let's write it here. and I come back to the table. So FL at the first iteration and FR have different signs. So we choose the second interval at the left. What does it mean at the left? It means the left endpoint, the left bound, will not change. It remains the same. But the upper bound, it takes the value of XR1. This is what it means at the left. At the left. So let's come back and apply that. XL will not change. FL will not change, its image of course. And XU here, we take these two values, we put them here. We can write 0,613 and here minus 0,071, or we can just write XR of the first iteration, of the previous iteration, and FR of the previous iteration. And that's it. The first four cells, you don't need any calculator. You just apply the rule of the sign. If you make a mistake, some people use FL, some students FL and FU. No, it's not FU, it's FR. Okay, there's always is this rule. And then come back and apply the rule of Abou Kamel. So let's do that here. Iteration number 2. Iteration number 2. Iteration number 2. XR2 equal the value of FU and FL. FU is this value. It's not minus 0, it's minus 0,071. Okay? And FL stays the same one. And XL stays 0, and XU is not 1, is XR1, is minus 0,632. So let's apply that here. Let's start with the F. So minus 0,071. We let a space here for the X's and minus 1. And we repeat exactly the same FU and FL in the denominator. Always I use parentheses because minus plus. So to avoid any confusion with the signs, you could have here minus 1, minus becomes plus. So be careful. And here we have 0, same, and here 0,630. This is XR, and this is FR of the previous iteration. And we obtain the value 0,571. But please check with me with your calculator. Check you obtain the same value. And we report that value in the table and also its image. FR2 is the image of XR2. And when I use the function exponential of minus x, I found the value minus, try to do that with me, minus 0.08. So it decreases, its absolute value decreases and tends to 0. So let's come back here to the table and report the values we have found. 0, 5, 7, 2, minus 0, 0, 0, 8. Now for the error, it's very simple. The current minus the previous over the current. That's what the formula tells us. It's the difference of the false points from the current to the previous over the current. Not FR, XR. The error is based on this column, not this column. So let's write it again here. We have the error. So this is the first thing. The second thing is the error at the second iteration equals 0.572 minus 0.6113 over the current value 0.572 by 100%. And I find the value. I go slowly because this is the first time we do this method. So try at least to work with me. You can also stop the video if you want and come back and check the result. 7 minus 71%. Here I use only one value after the dot. One decimal point, one decimal number. But for the others, I use 3 always. Because I work with calculator, 5, 6, 7, it's too much. For practical reason, this is what I used to do with my students, is to be realistic. But for the error, we don't need, are useless after 2, 3 decimal are useless. So we just have minus 7, 1.1%. The error is still big. And in exercises, in this example, once I reach 1%, I stop. Or when I reach 5 iterations, even if the error is big, I stop. I will not continue. So the break condition for me here is not to exceed 5 iterations. But if at a given iteration, before the 5th one, the error reaches the absolute value of the error reaches 1%, I will stop. And you will see the next iteration, we will reach that value. We reach a value that is less than 1%. So the method is really very fast. We are dealing with a little bit complex function. But in 3 iterations, you will see it will catch the solution with an error slower than 1%, smaller than 1%. So the third iteration, before to go to the third iteration, the sign rule. So at the left or at the right, we check FR with FL. This is positive, it's the same, positive, and here it stays also negative. So we still at the left, and this is an important thing in Kamel method. Generally, it does not oscillate at the left and then at the right, then at the right, like other method, the dichotomy method or bisection method. As we will see later in the last section of this chapter, some methods, there is only 2 methods actually in bracketing. This method and the dichotomy method. Dichotomy will oscillate. In general, there are very special cases where it oscillates. In general, it does not oscillate. So if you find here left, and then in the next iteration you find right, be suspicious. I have made you have probably made a mistake. So the method, if it catches at the left, the interval at the left, it will continue in the other iterations at the left. So we have here at the left. The lower bound will not change, and the upper bound, we take the XR and FR, we put them here. So we have here XR of the previous iteration and FR of the previous iteration. That is 0572 comes here, and minus 008 comes here. And let's go to the third iteration. Iteration number 3. And you will see it's the last iteration. Iteration number 3. Let's calculate XR 3 and its image. So XR3, we apply the formula of Abou Kamel, FU and FL, FU minus FL, in the numerator and denominator. So we have the value, it's not minus 0.632, it's the previous value of FL, minus 0.08. So I write it, minus 0.08. I leave space for X, and the lower bound does not change, it's 1, and I leave space, and over the same values, minus 0.008, minus 1. And here I add the value of X. So XL will not change, it's 0, but XU is the previous value of XL. That is 0.57.2. 7.2. So let's write it here. It's 0, and here is 0.57. And I find the value, again with your calculator, you will find the value 0.568. I take this value in the function, replace it in the function, and with the calculator, I get the value minus 0.001. So it decreases, it goes to 0, it tends to 0. And let's report them in the table. We have 0.568. As you can see, all the XR are between 0 and 1. And the value is minus 0.001. And for the error, the relative approximate error at the second iteration, as I said, current minus the previous value. That is 0.68 minus 0.72 over 0.568 by 100%. And I find the value minus 0.8. So it decreases to a value that is less than 1%. So here I have minus 0.8%. The value here is less than 1%. I don't need to continue with the other iterations. I stop here and I say, I'll take a look at the table, and I say that our solution is XR equal 0.568 I found it at the third iteration with an error equal minus 0.8%, but in absolute value is less than 1%. And that's it. So it's very easy to apply the method through this table, where each row represents a chord of Abou Kamel, and we have the position of the endpoints and their images, and XR and its image, the false point and its image. And the last column is how to measure the progress of XR. Always the current minus the previous over the current minus the previous over the current by 100%. And the error at the first iteration is always 100%. We will do that once, twice, 3 times in the tutorials, also with examples close to the physics, to the real world, with of course the level of first, second year. And that's it for this lecture. I hope I will see you in the second lecture to see the other points of this chapter. This chapter will be in 2 or 3 lectures. I have not yet filmed the other lectures. This is the first lecture of the first chapter. I plan to do it Friday, but unfortunately I got some problems and I could not. I apologize for that, but I will try. Always I will try to do the Friday, to upload Friday and Saturday. If I can't, then it will be Saturday and Sunday. Okay, so that's it for this chapter, for this first lecture. We will continue. There are still many details to see in this chapter before we go to lectures, to the tutorials next week. So keep following me. Inshallah, I will post a second video this day for the second lecture, and maybe tomorrow morning or maybe at the afternoon. I'm not sure, but tomorrow I will finish the lectures for this chapter. So see you again, inshallah. Peace.